Not every world that looks like Earth will spare your life. Step onto the surface of these so-called habitable planets, and you would last minutes, sometimes seconds, before invisible forces like radiation, crushing gravity, or cosmic particles tear you apart from the inside. The details behind these planetary death traps will change how you see the search for another Earth forever. So what makes a planet so familiar and so instantly fatal? You touch down on Proxima Centauri B. The ground is steady. Gravity feels right. For a moment, everything seems normal. But above you, Proxima Centauri is restless. This red dwarf fires off flares with a violence our sun rarely matches. Astronomers have counted hundreds, some so powerful they outshine the star itself. In 2019, a single flare made Proxima Centauri 14,000 times brighter in ultraviolet light for a few brief seconds. The planet sits just 0.05 astronomical units from its star, soaking up 10 to 60 times the X-ray and ultraviolet radiation that Earth receives. There is no thick atmosphere, no magnetic field to shield the surface. Radiation slams into every cell, breaking DNA apart, scrambling molecules. According to Dr. Guillaume Anglada-Escude, these flares happen every couple of days, each one strong enough to strip away whatever atmosphere the planet once had. Step outside without protection, and within minutes, your body's own chemistry turns against you. Organs fail quietly, one after another. You do not see it coming. You do not even feel it at first, but you never had a chance. Gliese 667. CC waits in the quiet of its own system, orbiting a red dwarf with just enough warmth to keep water liquid, if any remains. On arrival, the surface feels calm. Gravity presses gently. The air seems still. But the real threat is invisible. With no strong magnetic field, nothing stands between you and a constant rain of charged particles from the star above. These particles slip through whatever atmosphere the planet has, passing straight into your body. Every breath draws them deeper, where they begin to slice through cells in your lungs, damaging tissue at the atomic level. The process is slow, almost unnoticeable at first. Within hours, the damage spreads. Blood cells break down, nerves misfire, organs begin to fail. A magnetosphere specialist would point to the planet's silent core, stalled by tidal locking, unable to power a protective shield. An astrobiologist might call it a slow-motion disaster. You remain upright long enough to realize that something is wrong, but not long enough to survive it. Kepler 402 B2b circles a star much like our Sun, but its surface is anything but familiar. The planet's radius is 1.6 times that of Earth, and models put its gravity close to double Earth's gravity. The ground is solid, but every step feels like dragging your body through deep mud. Muscles strain. Your heart pounds, forced to work twice as hard just to push blood uphill. Lungs fight against a denser atmosphere, each breath shallow and unsatisfying. NASA flight surgeons compare it to standing in a centrifuge. Cardiac output nearly doubles, and exhaustion sets in within minutes. Even trained astronauts struggle to function at these forces for more than a short while. On Kepler 400b, the simple act of walking becomes a losing battle. Soon, your body refuses to cooperate. You collapse, pinned by your own weight, unable to rise again. On a world that looks so much like home, your heart simply cannot keep up. Trappist 1e orbits in the faint glow of a red dwarf, locked so tightly that one side always faces day and the other faces endless night. The twilight zone, the narrow belt between fire and ice, draws scientists and dreamers alike. Models from Dr. Martin Turbitt's team reveal a world shaped by forces nothing like Earth's. Here, the difference between day and night can be hundreds of degrees. That contrast drives winds across the Terminator at speeds up to 200 meters per second, twice as fast as the most violent hurricanes on Earth. The air roars, pressure shifts in waves, and the boundary between warm and cold never stands still. You step out expecting calm. Instead, the wind knocks you off your feet, sandblasting your suit and skin. Breathing becomes a struggle as the air pressure swings, never quite stable. The atmosphere does not crush you outright, but the relentless winds and sudden gusts leave you gasping, battered, and exhausted. Survival depends on finding shelter, if any exists at all. For humans, this twilight is a place of constant assault, where every moment outdoors is a fight to stay upright and alive. Venus has the same diameter as Earth. Its surface is rocky, solid underfoot, but every other detail is a warning. The air is 96% carbon dioxide, thick enough to crush a submarine. Pressure at ground level reaches 92 bar, the same as being nearly a kilometer below the ocean. Temperatures hold steady at 460 degrees Celsius. That is hot enough to melt lead, solder, and the seals on every probe we have sent. The Soviet Venera missions tried anyway. Venera 13 touched down in 1982, its hull groaning as the sensors recorded 465 degrees Celsius, wind hissing through the microphone. The probe survived for just 127 minutes before the electronics failed, the pressure seals buckled, and the camera lens clouded with acid. A human, unprotected, would not last 60 seconds. Step outside, and the pressure flattens your chest before you can draw a breath. Heat cooks every cell. Sulfuric acid clouds dissolve what is left. Dr. David Grinspoon puts it simply. At 92 bar and 460 degrees Celsius, Venus kills instantly. No theory, no speculation, just numbers, and the silent record of every probe that tried. Right now, over 5,000 exoplanets are confirmed, and most would destroy us in minutes. Survival is not common. It is an exception. Earth's odds are cosmic luck, and that luck will not last forever.